For this demonstration, I'm going to continue using the script project that I've used in earlier projects, but I'm going to create a new package and add it to the project. So I'll go over to Solution Explorer, right-click on Packages, New SSIS Package, and I'll come over here and rename this to Transformation. All right, everything that this package is going to do is going to happen in data flow. So I'll come over here to the toolbox, double click on that to add a data flow, and double click on that to go right into the data flow designer. So the first thing I need to do is add a new connection manager. So I'll come down here, right click, and I'll select a new OLEDB connection. And that opens up this Configure OLEDB Connection Manager. As you can see, I don't have any data connections in this project that I can use, so I need to create a new one. And that opens up this Connection Manager dialog box. And as usual, this is basically helping me create an ADO.NET connection string. So I'm going to go against the local server. And in this case, I want to use the AdventureWorks LT 2012 database right there. And I can test the connection. Succeeded. And there we go. And we have a connection defined to that AdventureWorks database. Okay, now I need to add an OLEDB source in order to read data from that location. So come down here to Other Sources and OLEDB source, double click on it. And that puts it on the data flow. I'll right click on it and select Properties. Oops, no, oh yeah, I didn't get the full menu for some reason there. I want Edit, because that opens up this OLEDB source editor. All right, the only connection manager I have available within the package is this AdventureWorks LT 2012 connection manager that I just created. So that's selected by default. And then I want to use a SQL command in order to access the data. This will be a real simple select statement. I want to select the first name and the last name from sales lt.customer. So this is more efficient than reading a table or a view because it's not going to return all of the columns that are available in that customer table. Okay, then I can preview this and look at the first 200 rows. Looks like, yeah, first and last names. Okay, looks like the data that I want. All right, so that configures the connection manager and identifies the data that I want to retrieve. And now I need to work with the columns here. So there's only two columns that I specified in the select statement. So there's only two available columns here. And by default, the component is going to use them all. It's going to provide all of that data to the output data flow. Okay, so that configures that data source. And now I want to add a script component. Right there, drag it onto the surface. Okay, so I immediately get this dialog box that prompts me for the component type. It can be a source, it can be a destination, or it can be a transformation. Transformation is the default because I guess Microsoft assumes that most of the time we as integration services developers are going to create custom transformations using the script component. And I kind of think that's probably right. So it's a good default. So I'll click on OK, and it creates that component. But notice that, unlike the script task in a control flow, we're not done configuring that component. Okay, and you can tell that by the red X icon there. So first thing I need to do is give it a source of data. There's that. And so the script component is going to get all of the first name and last name columns, the rows of data, from that OLEDB data source. All right, double click on that to open up the script transformation editor. Now, notice first of all that this is quite a different editor than for the script task that you use in a control flow. A lot more options and a lot more pages that you need to deal with. It's a much more complex component. Okay, so the first thing I need to do is, well, I'll notice here that by default I'm going to use Visual C# 2012. And now I need to define the input columns. So this information is coming from the data flow. So when I added this arrow, dragged it from the OLEDB source to the script component, that provided this information for the script transformation editor. But notice that nothing is selected by default. So I'll select all of that. Shortcut is I can select that checkbox up there, or I can select individual items. And in a real application, I'm probably going to have a lot more columns typically. And in this case, I'm only going to read those values, so I'll leave the usage type to read only. But if I was going to change the data, maybe this is a component that is going to do some sort of data cleanup or scrubbing or whatever, then maybe I need to make this read-write so that I can save those changes and they get sent down the other side of the transformation. Because again, keep in mind that I'm using this script component as a transformation. Okay, so that configures the inputs that are going to be used. And now I need to come over here to inputs and outputs. This is where you define what the output of this transformation is going to look like. So I'm going to expand this output 0, and you have this output columns node. So what I can do is add a column here to add a column to the output. Okay, and now I need to set a few minimal properties for this new column. So I'm going to start by setting the name to reversed name. So that's going to be the name of the column as it appears in the output of this transformation. Then I need to change the data type from a 4-byte signed integer to Unicode string. Right there, DTWSTR. And I'll set the length to 101. Now the reason I'm using a length of 101 is simply to ensure that I have a column large enough to handle a 50-character first name and a 50-character last name plus a space in between the names. Because I'm going to concatenate those together with a space. And the first name column is 50 characters, last name column is 50 characters. 101 is going to be sufficient to hold the data, even if both of those are maxed out. Okay, so at this point I have configured the component. I haven't written any script yet. I've configured it, and what all of this data is doing, all of the settings that I've done in this dialog box so far, is setting up the script component so that it knows what objects and methods to include within my script, within the Vista editor. So now I'll go back over here to the script page and click on the Edit Script button to open up the Vista development environment. Okay, so there's the environment. I'll hide these out of the way, but I have a nice little project structure. And just like the script task in a control flow, I have some code that's already written for me. But it's different code because it needs to do different things. There's a lot of help. There's various namespaces that are imported, but they're different from what's used by a script task. Some additional help. And then have a couple of methods, pre-execute and post-execute, as well as this process input row that is where you're going to generally add most of your code. Okay? So this is essentially the starting. So every time a row of data comes into this transformation, Integration Services is going to execute this method and make available the row of data that's currently coming in as an input buffer there. And because I didn't change the name of the inputs, I just left it as input 0. There's only one of them, so in this case is probably marginally okay. Then it uses that name as input 0 underscore process input row, because you could have multiple versions of this for multiple inputs. Okay, so I'm going to do a little bit of cleanup. We're not going to be using the pre-execute and post-execute, so I'm just going to delete that code, clean up the file a little bit. But where I would use those methods is if I needed to perform any actions a single time before or after processing all the rows in the data flow. Maybe this is a data destination that I'm configuring this as, and I need to create the container for the data, an XML file or some sort of custom file. I could do that in the pre-execute, and then in the post-execute I could do any kind of cleanup that I needed to do. That'd be just a couple ways to use those methods. Okay, so all my work here needs to be within this process input row method. So I get rid of the comment there, and I'm going to write some custom code. So the first thing I'm going to do is create a char array, character array, and I'll call it char array. And I'm going to use that row object that's being passed into the method, which gives me access to the data in the row that is currently being processed. And from that, I can access the first name property in order to get the first name. And then I'm going to concatenate on a space, and then use row.last name and concatenate that on. I'm going to take that concatenation and I'm going to convert it to a char array. Okay, so a very simple example of how you can access the data that's coming into the transformation. Again, keep in mind that this method is going to be executed for each row of data. If you were to do an asynchronous component, then I would need to use the process input, and I would have access to essentially a collection of all of the rows that were read into the component. So quite different programming for synchronous versus asynchronous. And then I'm going to use the array objects reverse method to reverse the order of the characters in that array. And then all I need to do is I'm going to then generate an output row. And in this case, it's the reverse name. Remember, I defined that name within the component editor. And so it knows and is expecting to output called reverse name, and it's of a particular data type, Unicode of 101 characters. And then I just need to new up a string and pass in that char array. All right, save early and save often. Okay, so again, I want to point out that this row gives me access to each row of data, and it's of type input O buffer. Now, given that name, you know that that was a custom object that was created by the Vista development environment based on the names of the input and output columns that I supplied in the component editor. Okay, another thing to point out is that you can explore a little bit more of what's going on behind the scenes looking at the other objects here. And in particular, if I open up the buffer wrapper, you can see this is the class where Vista defines that input O buffer and identifies that it has a first name. There's a first name is null, so I can test to see if it's null, and a last name, same thing for the last name, and then the reverse name as well. So this is the code that was generated because I selected those various options that I did within the script component editor. And if I don't like any of these names, including input O buffer, I can change the names in the script editor and the new names will be reflected in the code. Okay, so again, that's all I need to do. I'm getting in input of first name and last name, and I'm sending out a single column of reversed name. This is going to be the concatenated name with a space, and then all the characters flipped around. All right, so I'll exit out of that and click OK here in the editor dialog box. All right, and my red X icon goes away, so presumably I've properly configured the component. All right, now I need some place for that data to go. And I'm just going to use a bit of a kludge here. I'm just going to put a multicast operator there and have the data flow go out there. And all the multicast is doing is it's serving as a placeholder component so that we can examine the output of the script component. Obviously, in a real application, I want the data to go someplace. So I'd have a destination or another transformation or whatever I need to do for the package. Now, the reason I used a multicast transformation instead of a destination component was just to keep this sample as simple as possible. If I had used a real destination, I'd need to create a target table with the correct columns and data types, but my purpose here is to demonstrate the script at work. The multicast transformation really is just a handy placeholder for this type of package development and prototyping when you're not yet working with the final data destination. Its main benefit really is that it requires no configuration for this use other than to attach the data flow path from, in this case, the script component. So it's a handy technique as you're developing packages. All right, I want to be able to see the data, so I'm going to right-click on this, enable the data viewer, and I get that nice little magnifying glass icon there. By the way, if you've used older versions of integration services, there were actually more complex options there for data viewers. This would actually open up a dialog box, and you could select amongst grids and different kinds of data viewers. But Microsoft greatly simplified the data viewers in as of SQL Server 2012. So it really makes it easier, because I think most people use grids anyway, so why bother with the other ones? Okay, so I'm going to go ahead and execute the package. And it'll run. It'll read the data from that data source from the table, from the script component, and then here is the output data. So you can see the first name, the last name. Notice that I get the input columns by default in the output. And then there's the reverse name. So Orlando G. Yep, looks right. And Keith Harris. Yeah, okay. So it looks like it's doing what it needs to do. Now, the important thing to understand here is that that process input row method executed for each and every one of these rows. And as you can see at the bottom, there's 847 rows that method processed. So the method executed 847 times. And as part of that, each execution, it added a column to the output. And that's what you can see here. All right, if I move this out of the way, can see that I had 847 rows that passed through there. Scroll down here, and I'm currently here executing. These haven't completely been read, and so that's why the yellow spinning icon is still happening. But I can detach that, and it'll complete execution, and you can see that the package executed successfully. So I can close that and stop that package execution. By the way, the data viewer only stays open as long as the package is executing. So I didn't need to close the data viewer. As soon as I stopped execution, or really debugging of the package, then the data viewer would go away. So the moral there is to make sure that you've examined all the data, copied it to a spreadsheet, done whatever it is that you want to do with that data before you end execution of the package. Because then the data in the data viewer is lost. It doesn't stay open after execution. Now that you know how to add script to a data flow by using the script component, what can you actually do with it? Well, as with the control flow in the script task, the short answer is really anything you want. But there are a few specific examples of real-world ways to enhance your data flow through custom code. One is to create custom data sources. Sometimes you need to read from legacy flat file formats that the flat file source doesn't support, or to read from the proprietary databases for which no existing provider is available. In that case, you can use the script component to create a new data source. You can also create custom data destinations. And again, sometimes you need to write to those same legacy or proprietary data stores and formats. In that case, you can use the script component to create a new data destination. And then, of course, custom transformations. Sometimes you need to manipulate the data in your data flow in ways that the built-in transformations don't support, such as calculating checksums or hashes or encrypting or decrypting data. You can use the script component to create a new transformation and use the features of the .NET framework. So for example, .NET framework has robust support for encryption and hashing, and so you can take advantage of that within the script component.